is on. Okay, now, so first we in the DNA we have following properties. So suppose that any DNA sequence will look like this. First we have DNA sequence name, then we will have the sequence. Now this is called as the FASTA format, and in this FASTA format of the DNA sequence, we will have following. First, we will have the name of the DNA sequence, and then we will have the sequence. So every DNA has a sequence. So first we have created the property name sequence, and then so so if we have sequence, then we will have length also. So if we talk about this sequence, then we have the length, some length will be associated with this sequence, and then we have complementary sequence. So I have already introduced the complementary sequence is nothing but we calculate the complementary sequence by pairing A with T and pairing G with C. Okay. So you can see here that the complementary sequence in this case will be for A we will pair with A with T. You can see here A will be paired with A will be paired with T. Similarly, T will be paired with A. Similarly, G will paired with C, and C will be paired with G. Okay, now T, A, T, A, and T, A, T. Okay, so this is the complementary sequence. Complementary sequence. Now, every DNA sequence we will have a complementary sequence related to it, and now we will have his valid sequence. So in DNA sequence, there are four characters are only allowed. That are the bases. Okay, so A, T, G, and C's are bases that are basically DNA is made of these bases. That's why if we have another character that are not A, T, or G, A, T, G, or C, then we will call that DNA sequence as invalid. So we have again a property is valid sequence. Okay, now again we will have the property sequence length complementary sequence. Okay, no, we don't have. So now we are writing a uh, constructor. So in this constructor we will pass sequence. Okay. Now so we are passing here sequence. Then we need to write here self dot is valid sequence is equal to sorry self dot sequence is equal to sequence. Now we have created these variables are private variables. Okay, to get these variables we need to add public methods to get these variables. So the first method that we create here is to get the length of the DNA. We will write get length of DNA sequence, and then we will write here self. We will just return self dot sequence. Whether you can directly return like this, or you can just set the length property. So it would be better that you should assign the length here. Okay. Why it is better, I will tell you. Now you can see why we are calculating the length here. So first we have created the length here, length property here, and in the constructor we are just assigning the sequence to the sequence value to this private variable, that is the private property sequence. Okay, now suppose that if any user don't want to get the length of DNA sequence, then writing the length in constructor will be waste of calculation. Okay, so suppose that if you don't want to, if you don't want the length, then we should not calculate the length, because constructor is called directly, constructor is automatically called when you create the object first time. So that's why for saving the memory we will not call this we will not set the length value here. Okay, so if the user wants, then we will calculate the length and will return the length. Now we are getting here length of DNA sequence. Now similarly we want to first check is valid sequence. Okay, to check is valid, we will write here allowed characters. So what are the allowed characters? It is better that we if you want to create some constants in your program, then it is better that you create in a new file. Okay, and name that file as constants. Okay, in this constant we will create mm, lot basis or what, A, B, C, D, G, and C. So allowed basis in DNA is what, A, P, G, and C. Now we can get this constants variable, this variable from this constant module. So to get that, we will write here no constants import. Okay. And now you can use here for sequences in self dot self dot sequence if sequences, or you can just name it sequence. Sequence not in what, not in allowed basis in DNA sequence. Okay, and self dot what is valid sequence is equal to self dot is valid sequence is equal to what, false. Okay, and we will return from this, return self dot is valid sequence. If this is if this is not true, means if all the sequences are present in the allowed basis in DNA sequence, then we will set self dot is valid sequence is equal to true and will return. Or there is one another way, you can just write here, you can skip this. Okay, always try to write better code and write here break, and otherwise is valid sequence will be true and you can return this self dot is valid sequence. Is this clear everyone?
Yes, sir.
So why it is better to write here break? Okay, actually, in the program we don't want usually to write more than one return statement. Okay, so try to make only one return statement if possible. So no, this program is not correct. Okay, so you can see here. First we will now what is happening here. So first we are checking if sequence not in allowed page sequence we have written here self dot is valid sequence is equal to false. Okay, so if this loop terminates. Okay, so if this loop terminates, then it means that there are chances that this loop can terminate by two ways. First we will just it will just complete the loop and it will return. Okay, and second scenario will be that it will be it will return by by encountering this break statement. Okay, so I think this is not correct. Okay, we'll first check if self dot is valid sequence not is equal to false, then we will write here self dot is valid sequence is equal to true. Okay, so because why we written here like this, so self dot is valid sequence can have two properties. First, it can be none or it can be false. So if it is false, then we will just return self dot is valid sequence. Okay, and if it is none, then we are setting the value as true. uh, we are checking we need to calculate the complementary sequence. Okay, so we can create a complementary base pair here. Complementary base pair. So complementary base pair will be a dictionary. So A will be paired with what? Similarly, G will be paired with C. Similarly, T will be paired with what? A, and C will be paired with what? G. So we have a complementary base pair. So we can get this complementary base pair here. Okay, so first we need to write get complementary sequence, and then we will write here self, and then we will write n variable. Okay, so mm, okay, so we need not to create the complementary sequence. So get complementary sequence, we need to calculate this. If self dot complementary sequence not equal to none, return self dot complementary sequence. So why it is important, I will tell you. Otherwise, we will write for this in self dot what sequence complementary sequence plus is equal to what base dot. This was complementary base pair. So you need to call this complementary base pair dot get. You need to write here keyboard base and then return self dot. So it's, we can modify this method also. So you can write here if self dot complementary sequence not equal to none, then we need to do it. And then return this. Because why we are doing this? Because calculating the complementary sequence is a CPU intensive task. Okay, so if we have a DNA sequence having the length of more than 1 lakh base pair, okay, so suppose that if user calculates get complementary sequence first time and we have calculated this, okay, so it will be calculated once. Then suppose that if user calls this again, then we will not. So if a first time user calculate, if first time user calls this get complementary sequence, then we will set the value of self dot complementary sequence. Okay. Again, if the user call this get complementary sequence, then we are writing here condition what if self dot complementary sequence not equal to none. This will be true. Why? Because we have already set the complementary sequence. We will just return the value. We will not calculate it again. Is this clear, everyone?
Yes.
Okay, so we have created here. So we have written here get complementary is valid sequence and get length of DNA sequence. Okay, so these are the following method that we will use. So we can take suppose that I am creating a object. Okay, so DNA and we need to pass here the bases. So ATGCT. Okay, now we are printing print is valid DNA and we will call here DNA dot is valid sequence. Okay, and again now we will call print is okay complementary sequence. DNA dot get complementary sequence. Now you can call length length of sequence. That is what DNA dot get length of DNA sequence. Now run this program. So you can see here what is the output of this program. First, it is telling is valid DNA true. Complementary sequence complementary sequence it is telling none. Okay. So length of sequence it is telling us 6. So complementary sequence it is returning none. So there is some issue in our program. So get complementary sequence. Okay. So we need to write here is equal to here. Okay, so first we need to initialize this. So what is the issue here? First we need to initialize this as empty. Okay, and then you need to because initially it will be none, and if you not initialize then you cannot append the character here because you cannot append none in the we cannot append character in the none type object. Okay, so that's why it is giving error. Now it will not give you error. So you can see here. So it is telling is valid sequence DNA true complementary sequence TACGAT. So you can check here our DNA is what ATGCTA and complementary sequence is TACGAT. Okay, and the length is 6. Is this clear, everyone? Can we move to another part? Okay. So why we have written here this? Because this is a whenever you create a file in Python, then it is called as module. Okay. So if you are writing here, if name is equal to main, then it is thinking that this module is you are running this module only. Okay. So if you import this module to another class, then this method will not run in that case. Okay, because that time this module will be not the main module. Okay, now we need to first I am creating a sample DNA data file. So this sample DNA data will have first we will have DNA. So first we will have name. Suppose that I am writing here PMK12. Yes, we have DNA sequence AT GCTCTCTG. Okay, for that. Okay, it would be better that we could create a random DNA sequence file. So I am creating a random DNA sequence file. So okay, in that case we cannot give the name. Okay, so it is better that first we need to rename this to text. Okay. So here we will create the name is why it is giving me error. Okay, no, it will not give error because that was considering that file as Python file. That's why it was giving error. So now it will not give error. So TGAMK, okay, now AMK underscore one and ATGCT. I'm getting a random DNA sequence. We will be changing some part of it. Okay. The last I am creating a invalid sequence. Okay. So this is an invalid sequence. Now we can add a new line here also. There is no any issue. We can add here also. So this is a sample data file that is a FASTA. It is a FASTA file. Okay. So it is in the format of FASTA. Okay, basically DNA sequence are written in FASTA file, and this is the default. Where this is the syntax of the FASTA file. First, it is the DNA sequence name. This then it is the sequence of the then it is the sequence of that FASTA file. Okay, so now we will create a process FASTA.py. So we will to process the FASTA file. Uh, write a we will write a program here. Okay, so if I am creating a class here, class FASTA master handler. Okay, you can hear FASTA file handler. FASTA file handler. So in the FASTA file handler, we will have first in the FASTA sequence, we will have the sequence name, then we will have the uh, okay, so first we will have the file. I am creating a file is equal to none. Then we will have file name that is none. Again, one property we are getting number of sequences none. And now we will file name number of sequences is none, and then complementary FASTA file is equal to none. We will create a complementary FASTA file also. So I think this file name, yeah, okay. So we can create like this, no problem. If init getting the constructor, and what should we pass in the constructor? Can you tell? File path. Okay. Only one property that we will be needing from the use that we will need from the user, file path. You can write your path only. So we will assign this self dot file path is equal to path. Now we will write one method, def process FASTA file self. Now to process this FASTA file, we need to first we need to open this file, and then we need to read the file one by one. Okay. So first we will open this file by using with. Okay. Open. So we will open the file in the read mode, and the file path is what? Self dot file path as what? As what? Self dot file. Okay, not this. Self dot. Okay. Now we will read the line one by one. For I mean self dot file dot what? Why it is giving the error? Okay. So we will read this file self dot file dot read lines. Okay. Now if line dot starts line dot starts with the character greater than symbol, then we can say that what. So you can see that when you see this FASTA file, so first we have uh, first we have the DNA sequence name, then then we have what, the DNA sequences. So in because these are in the multiple lines, so first we need to read this line, and if we encounter the first character as greater than symbol, then we will say that this is the name of the fast this is the name of DNA sequence, and the rest characters are what? Rest characters are its sequence. Okay. If line dot starts with greater than symbol, then suppose that I am creating a dictionary here. DHCT DNA sequences equal to none. Okay. Now we will append DICT self dot DICT dot line dot R strip R strip. Okay. Equal to empty. Else self dot. So if this line is not starting with, if this line is not starting with what greater than symbol, then this is what, this is the sequence. Then we need to, first we need to create a temporary variable also. So we will write here m dna sequence name line. In this case, why, what is the importance of this, I will tell you. Then we will call this m dot plus equal to line dot r strip. Okay, now it is giving the error. Why it is giving the error? Because this self dot, we have created this as a private. Okay, because we are in inside this context. This width had this width had basically. So why should we not create like this? Self dot DNA sequences does not support. Okay, okay. So first we need to initialize this. It will because why, what was the error? Because it is not understanding that this is a dictionary. Okay, now I think this so will get over now. Now if this program terminates, then we will have the, so by this way we can calculate the complementary sequence. So now we can write this we now we can write this. Okay, so it is better that we can so this process faster file is finished. So now we need to save this into a, so now we want to get the complementary sequence of this. Okay, so to get the complementary sequence, first we need to create the object. So to create the object, we need to call the from DNA import DNA. What was the class name here? DNA. Okay. So from DNA we are importing the DNA. Okay. Now DNA class. So I am talking about this DNA class. So I am going one by one into this dictionary. So we are reading this four items self dot DNA sequence dot is, or you can say here items. So so or it is better that because why I'm creating the object is that because we have already written the formula to calculate the complementary sequence in that DNA class, so we can use that. Okay, so that's why I'm creating the object of that DNA sequence. So I am writing So in this method we can pass one more thing is that result. Okay, so in this process FASTA file we need to pass one more thing is that result FASTA file result path. Okay, and this result path we will create result complementary FASTA file path is equal to. Now we will assign this value here to result path. So we are calling here four items in dot dictionary dot items, and now we are in what self dot result path in write mode. Okay, now we will save the first we will write as result file, and in this result file result file. Okay, so here we have wrong name result file. Now we result file dot write what items. So these items, and now result file dot write lines self dot. Okay, so this we can get the so this is our dictionary, and to get the sequence from this dictionary we will call self dot dict DNA sequences, and then what items. Okay, and now okay, so items, and we can create here DNA dot get complementary sequence. And this program is finished, so we can call this if name equal to main, and then we need to create what is the object of this. So we are creating here process. So what is the path of our DNA sample DNA file? So we can copy the path from here. So it is telling us that you should use here this, or you can tell this as this is a path. Okay, so FASTA process dot we need to write here process FASTA file. Okay, to we need to give the path here. Okay, so we will give the path as it is better that you write this thing in a constants. Okay, so we can write this here. Paste DNA path is equal to R, and you can copy this here in the constants, and name should be valid. So here we should write here DNA say test DNA file path. You can say here test DNA input file path, and here we will write test DNA output file path. Okay, and we can write here result dot txt. Now we can call this now constants import what test DNA input path and test DNA output path. You can pass here input path and output path. I'm running this program. Okay, so it is giving me error. What is error? It is telling that key error. Okay, so why it is the key error? For item in self dot dict dot if line dot start with this, then okay, so we have written here R string. So we should write here R string also. Now our program is again we have error. So it is telling us with open as result file expected str bytes or okay we have it is telling that it is none type. So why it is none type? We have not assigned here. So we have assigned here self. Okay, you need to write here self. Again it is telling that we have key error where. So in line number 25, self dot items dot get complementary sequence. It open as write mode result file dot write line what items. Okay, is Can only concatenate str not none type to line number 35 is DNA output file and then get complementary sequence. Okay, so something is wrong here. So in the result file what we have, okay, so this is, and then okay, so we have written here r strip. So you can easily check what is happening, what problem is happening here. Okay, so to check what is happening, because our issue is happening here, it is telling that we have issue here. So you can check, you can add a breakpoint here and you can run this program in the debug mode. So now we are here and in the get complementary sequence we have, this is none, then we have get this, and self dot sequence is what, apgc, then this is not any issue. Okay, so this, why it is calling, so we need to call this. Okay, now it is calling. Yeah, we have error here. So why, what is the error? So what is the base? K. Okay, so one of the file we have the k. Okay, so the k is an invalid sequence, so that should be not present in our DNA. So what is the, so okay, so we need to modify this method. Okay, so here you can write here is, why it will not give error. Okay, in this result.txt file we have only amk. No, we have not changed the name of this. Yes. So what was the issue here? Basically, all the name of the dictionary was same. So sorry, all the name of the DNA was same. That's why you, when you will create a dictionary, and you will assign, first you will put this item in the dictionary. Okay, so you will have the key name amk1. So again, if you put this, so again if you have name amk1, so that will be equal to this, so that the value of that will be overwritten. Okay, so now we need to change here that, and now I'm running this program. So okay, again we have this only. Is some issue in the program. So okay, you don't, uh, you should not write this. Okay, so this is not a good way. So what was happening there, I will tell you. So you need to write like this. Okay, so this is your this is your result. Okay, so now you can, it was our sample data and this is our result file. That is basically the complementary sequence of the sample data file. So you can see that, suppose that we are comparing this AMK4. Okay, so this AMK4, yeah, this is AMK4, and you can compare the DNA sequence here. So I'm writing here, is it complementary or not? A is paired with T, T is paired with A, and G is paired with C, C is paired with G. So it is good. So now we have calculated the complementary sequence. Is this clear, everyone? So if in any
Yes,
part
sir.
of the code, so you can ask. So have you any doubt in any part of the code? No. Okay. So now we have covered the two parts. So first our task was to get the complementary sequence of the every DNA sequence present in the file. So now our task is to calculate the codons. Okay, to get the codons from a dictionary. Sorry, to get the codons from a DNA, we will so we will split the DNA in three parts. Okay, so we will split the DNA in three character at a time. Okay, so what I'm telling is that if you want to so what is codon? Codons is basically, suppose if we have this DNA sequence, then codons are the three character pairs. So these are the codons. So this is the codon, then this is a codon. These are the codons present in the DNA. Now this last one is 80, so this is not a codon. So if any DNA sequence have not have if any DNA sequence if the length is not the factor of 3, then you can add a in the last. Okay, so suppose that it is a length, it is, suppose that if we have in the last a, then you can add double a. So uh, if you have two character, then you can add a single character. So it's on you, you can add you need to make this here. You need to make the length 3 as 3. Okay, so these are the changes we need to do. So to calculate, to get the codons from the dictionary, sorry, to get the codon from the DNA. So to get the codons, we just can modify our DNA class. So we can write here codons equal to none. And now we can write a method def calculate calculate codon and self. Okay, so every codon has a name. Okay, so if it is ATG, then it will have a name. Similarly, this is a CTA, then we will it is also it also have a name. Again, CTA.